Good morning, good afternoon, good evening, everyone, depending on where you're joining us from today. And welcome to Destination Scale. We'll give it a few more seconds for everyone to join before I get started here. As Chuck said, you should see a chat function on the right-hand side of your screen. Use it to say hi if you haven't already, introduce yourself, and let us know where you're coming from. I'm Melissa. I'm in London. My accent might be a giveaway. I'm the EMEA Field CTO here at Kong, and my role is all about inspiring business change through APIs and microservices. I've been at Kong for 2 years, and I was at MuleSoft for 5 years before that, doing a similar thing. So I've been very much part of defining what an API-first approach means and how to adopt it. And this session is all about that. We're going to look at how we can automate the API lifecycle like never before with APIOps to give you both delivery speed and delivery quality at scale. This is Acme. It's a large bank with a sprawling tech landscape. The company's been around for several decades, so they've got a lot of legacy systems and tools and multiple siloed engineering teams. They've built up a bunch of APIs and services of differing standards, but no one's got a single view of all of them. As part of Acme's digital transformation, they're migrating most of their workloads to the cloud and Kubernetes, and they're adopting more of a consistent API microservices-driven approach. And the teams here are constantly trying to balance these ongoing modernization efforts with the increasing demand for innovation, which Acme needs to stay relevant as a business. In the mortgages team, they're refactoring their legacy code as they migrate it to the cloud. And they've just identified the next API they need to build. And Emily's just finished designing that API. She's reviewing the spec with her team. They all agree the spec looks great. So as per their normal process, she sends it off to the API platform team for review and moves on to her next task. The API platform team owns Acme's API platform as well as the overall architecture. They host and manage the platform on behalf of the rest of Acme, with the goal of raising the overall engineering standards across the organization. They need to make sure that whatever they accept for deployment into the platform meets the standards of everything else already there. So to do this, a group of them meet once a week and they go through all the new APIs and services that have been submitted, and they check them for standards. Sadly, in this case, Emily's spec is not approved. It turns out that there's a whole set of standards that Emily just doesn't know about. They're probably documented somewhere, probably updated occasionally, but they're not very well communicated and definitely not in a developer-friendly way. So a week after she submits it for review, the platform team rejects Emily's spec and it gets pushed back down to her. This is pretty embarrassing for Emily. She's getting called out in front of her peers for not doing a good enough job and told to redo her work. And that's really damaging to her morale. This is also a huge waste of everyone's time. Emily's going to have to repeat the same work unnecessarily. And the platform team are doing these reviews manually at scheduled intervals. So there's several days wasted even just waiting for that review. And this is just the first iteration. How many more cycles is it going to take before that spec's good enough? How much is that going to delay the end go live? But it's not just Emily and the mortgages team that suffers here. Acme's following best practice, and they're using a single API platform for global discovery and reuse across the business. And this means as adoption grows, the platform team needs to onboard and support more and more teams across the organization, and then have more and more APIs coming in for review. And this is on top of all the other work they have to do in the platform. Their backlog just keeps growing. So the platform team ends up being stretched really thin, and rather than spending enough time fully reviewing every API, they end up having to prioritize and to rush things to make sure that everything gets done in time. Not to mention the fact that compliance becomes a nightmare. With different APIs built by different teams in Acme, it is just too much to manually validate that every single service complies with local regulations. So they hire as many test engineers as they can justify the budget for. And this helps a little bit. But as well as getting expensive, it's not long before they're also overwhelmed and stretched too thin as the API adoption grows. And this means that things fall through the cracks, which isn't so good for the operations team, who are responsible for maintaining the overall IT estate. Enough has fallen through the cracks that there's a lot of bugs and errors in production. Nothing is guaranteed to be consistent, and deployments are pretty painful. In fact, they refuse to deploy new code more than once a week because it causes so much instability. These poor folk regularly get called in at weekends to fight whatever the latest fire is and try and minimize the impact to Acme's customers. Elsewhere in Acme, the mobile team operates a little differently. The team here is very autonomous. They've been given a lot of freedom so that they can get customer-facing applications out as quickly as possible. This mobile team is a newer team at Acme, and it was created with the sole purpose of building rich digital experiences for Acme's customers as a reaction to the mobile-only banks that were threatening to displace them. As usual, the team is rushing to get something out. They're about to release their latest open banking application, and this one is a big deal for Acme because it's the first time that they're exposing actual API endpoints to customers, as well as releasing a mobile app. Since this mobile team doesn't follow the same governance processes as the others, and they've seen the delays getting APIs live elsewhere in Acme, they've decided to do things their own way and bypass the API platform team altogether. But they were in such a hurry to go live on time that they just focused on the implementation code and missed some API best practices. And this means that their APIs are inconsistent. They're hard to find, they're hard to access, and they're hard to use. And this puts people off, whether that's internal or external consumers. Their prospects of this open banking application now are much more likely to go to one of their fintech competitors who know how to treat APIs as products, because this is what makes an API consumable. Making matters worse is the fact that someone in the mobile team forgot to secure one of his APIs when he published it. This then got exploited, and Acme detected a data breach affecting 15 million customer accounts. Acme started off with all the right intentions here. They needed to modernize and APIify the business so that they can continually innovate and delight their customers through differentiated digital experiences as they migrate to the cloud. But they've ended up in this situation where they're trading off between speed and quality. They aren't seeing much of the business benefits of APIs and microservices. In fact, they're creating just as many problems. And this is because whilst they're modernizing the technology in their estate, they aren't modernizing their processes. If Acme had just a couple of services, these laborious manual processes they follow might be okay, but they just don't scale. And no matter how much Acme invest in technology or in QA, they cannot effectively adopt APIs and microservices in a sustainable way. I'm curious how many of you here today are in this position and having to make this trade-off right now between delivery speed and quality. So on the right-hand side of your screen, next to the chat tab, you should see a polls section. And in there, I've got a question for you all. Possibly not to the level of Acme, but are you having to choose at the moment between getting things delivered quickly and ensuring that everything is high quality? You enter the competition to win a prize if you respond, and we will have a look at the results at the end of this session. But back to Acme. This is where APIOps comes in. APIOps is the automation of the full API lifecycle. It combines DevOps philosophies when it comes to iterative design and continuous testing with GitOps philosophies in terms of automated declarative deployments. Where before we saw these manual, costly, and error-prone activities at Acme, now we automate all of it. Let's go through what that actually means. So we know the API lifecycle, right? This is nothing new. Best practice means that we design an API before we build it. And then once it's deployed, we add governance and operational policies to manage it, before then making it discoverable to consumers in a portal. And then there's all the ongoing operations. And this life cycle continues going round until we retire the API. What we're going to walk through now is what this life cycle looks like when we follow APIOps. Firstly, see that the actual steps in the life cycle haven't changed. We're still following the best practice that we've established over the years. But what you're going to see now is that the processes that we follow at each step and between each step have changed. So at design time, we use a design environment like Kong's Insomnia to easily create the API spec, which is typically a Swagger document. And we can also embed governance here. Any constraints that we know about, any best practices that we know about, let's explicitly add that governance to the design. In Kong, we support this by letting you define runtime plugins within the spec, like you could add in OIDC for security or a rate limiting plugin or your own custom plugins. We also create a test suite for that spec. And here we need to check for several things. Do we get the responses that we expect in certain conditions? Are the right plugins applied? What's critical here is that the tooling we use gives us instant validation. And by that, I mean the linting of the spec against best practices, the ability to run those tests locally and validate instantly what you're building. As the designer of the API, you need to have self-serve tooling that makes it easy to do the right thing from the beginning. We don't want to end up in the situation that Emily found herself in. So when you've created that spec and validated it locally, then you push it into Git or whichever version control system you use by raising a pull request for this new service. This triggers a governance checkpoint embedded in our pipeline. Before any time is spent building the API, we need to make sure that what's going to be built follows our company's standards and is aligned with everything else in the ecosystem. We automatically invoke the API tests that we built earlier and any other governance checks that we want to include at this stage of the pipeline. For example, are certain plugins actually specified in the design? Like before, there's going to be checks that the platform owners will want to do for every API that Emily and the designers won't have awareness of. But unlike before, this is not a manual review. This is now an automatic and therefore instant process. And in Kong, we enable this through the command line tool inso. So if the spec fails any of those tests, it gets automatically pushed back for more work in the design phase. Emily doesn't have to sit around waiting for a response from the platform team. She can get pulled up in front of her team during a review meeting. She just gets an instant automated notification that something has to change. And because this is an automated check embedded in the pipeline and triggered by default when a new spec is pushed into Git, it means that you get 100% coverage of these checks for every API and service that's being designed anywhere in Acme. So we are now consistently and instantly catching any errors or deviations from our standards as close to the beginning of the pipeline as possible. And this means that they are much faster and much cheaper to remediate. In fact, it's been estimated that to find and fix a bug now at design time costs 1% of what it would cost if we found it in production. When all of those tests pass, then we have a validated spec and we can now progress onto the build phase. And here we build our API in the normal best practice way. We use the spec as the contract to tell us what the service needs to do and what the interface needs to look like. And then we use those tests as we go to validate that the service we're building meets the spec. As before, when the developer commits their code saying it's ready for deployment, a series of tests are triggered. We automatically execute the tests that we built at design time again to make sure that this API still meets our best practice and that the interface that's been built is what was specified in the spec. These tests are actually our unit tests, and they'll also make sure that the implementation of our API functions how it should. And there'll probably be additional tests that you want to carry out at this stage, still automatically. If any of those tests fail, we know immediately. We don't deploy the API. We go back and we make the necessary changes until the implementation is how we need it. And we can keep executing these tests for continuous validation of what we're doing. And then when those tests pass, we progress forward to deployment. And now this is where we start to see more of a GitOps approach. Because when this round of automated tests has been passed, we then automatically generate the declarative configuration file for this API. And this is one of the central components of GitOps. It is all about declarative rather than imperative ways of managing deployments. This is the modern way of managing infrastructure because it has so many benefits in terms of deployment speed, auditability, and repeatability. And these are benefits that we need when we consider the level of scale and complexity that we're managing now compared to a few years ago. For those that aren't familiar with a declarative approach, it's a lot more streamlined than the traditional imperative approach. If we're doing things declaratively, we just specify what we want the end result of something to be. Whereas with imperative, we also have to specify how to get that end result. So in the context of deployments, if we're implementing CI/CD the imperative way, we write a script that orchestrates every step that needs to happen. Call this admin API, extract that value, use it to call this API, add the policies with that API, and so on. This is a bit of a pain to first set up. It can be a pain to debug if something goes wrong, and it's also a pain to rewrite if one of the underlying admin APIs changes. But if we're doing this the declarative way, we don't need to worry about any of that. We just tell the platform what it needs to look like when that service has been deployed. And the platform itself takes care of how that's achieved. This simplicity is why every modern deployment approach is now declarative. And the same is true in APIOps. The beauty here is that we don't even need to write that declarative config file ourselves. In Kong, it is automatically generated from the API spec, so we can have it instantly whenever we need it. And because it's generated from the spec, it'll be completely accurate and 100% consistent with the spec. So we know that nothing in the spec will be forgotten about, and there's no chance of human error in that deployment process. So that declarative configuration, having been automatically generated as part of the pipeline, instructs the API platform what it needs to look like once that service has been deployed. And the platform goes off and configures itself. So we end up with our service registered in the platform and with the various security, governance, and operational plugins for that service configured as well. And we support this in Kong Gateway and in Kong Mesh. It's also worth noting that this declarative configuration file is stored in version control, along with the spec, the tests, and the implementation for the service. And this means that we've got a complete, searchable, and auditable history of every deployment we've made. So if ever there's a problem once we've deployed the API, then we can very easily roll back to a previous state. So it's not just that we've made deployments easier, but rollbacks as well. Of course, once we've deployed the API, we'll need to validate that it performs how we expect and check that we haven't caused any errors. We're now in an environment where other APIs, other microservices, and other code is deployed. So we should do some integration testing, security testing, or performance testing, whatever's appropriate depending on where you are in your software development lifecycle. So we'll run that series of release checks before we actually publish this API and make it discoverable. These checks should also all be automated, although you may want to have a final sign-off as a manual step before you push that publish button. When you're ready to publish the API, then registering it in the portal, enabling self-serve access, and adding the spec for the API should be an automated process as well as ensuring that you can constantly deliver at pace. The only way to ensure that every API and service is discoverable and documented in the portal is to automate it. And of course, we support this in the Kong Dev portal. Now, what we've built up as we've gone through this API lifecycle is an inventory of assets that enable us to operate this service on an ongoing basis in an almost entirely self-sufficient way. If we need to scale out the API, for example, to handle high throughput, that can be completely automated using the declarative configuration. Since this is version controlled, we'll see a completely repeatable, identical deployment to before. The overall result here, when our API lifecycles follow APIOps, is that the continuous automated testing and deployment means that we catch and resolve errors early, speeding up deployment and raising quality. This is the only way to operate continuously at scale without sacrificing productivity because of manual checkpoints or have lower quality because of the need for speed. Acme have just adopted APIOps, and in the mortgages team, Emily's working on another API. As before, she's following best practice by doing this design first. But unlike before, the tool she's using to create her design gives her instant feedback on it, so she can make sure herself that the spec she's building doesn't violate any policies. She skipped out several days of back and forth with the API platform team getting this right. Instead, it just takes her a few minutes herself. And then once her spec meets standards, she then has the ability to push it directly into Git so that it triggers the next part of the automated APIOps pipeline. This creates a pull request in Git for the API platform team to then review and decide whether to approve and merge it into the code base or to reject it and send it back to Emily for more work. Life is very different now in the API platform team. They've automated the API review process and applied it to every single API and service coming in for review. So they've got 100% coverage of every quality, every security, and every compliance check across every single API being built at Acme. This means that the team isn't overwhelmed anymore. Their QA costs have also gone way down, and they're no longer the bottleneck for APIs being deployed and published. If there was a problem in Emily's spec, she wouldn't have to wait for the next scheduled review session because these automated reviews are triggered whenever a new API has been submitted. But this time, there weren't any issues with Emily's spec. The tool she's used at design time made it really easy for her to do the right thing from the beginning. So the chances of her API meeting standards now is much higher. Once these automated tests have passed, the last step here is the automatic generation of that declarative config file for Emily's spec. And this is then added to Git and picked up by the operations team. Not that they really have to do much. The API platform configures itself based on the declarative config. It registers the endpoints, the methods, and it applies and configures all the necessary plugins as well. The platform also automatically makes the endpoint discoverable in Acme's portal. So Emily's API is deployed immediately and smoothly. Deployment is much more likely to go smoothly with APIOps because A, everything has been tested, so the chance of introducing problems is lower. And B, the deployment is completely automated and declarative. In fact, deployments are now so repeatable that the operations team have removed their limit of 1 a week. They're now deploying in a truly continuous fashion, and they can meet the increasing demands as API adoption accelerates across Acme. Of course, there'll still be times when things go wrong. That is unavoidable. But the impact of something going wrong is now much easier to minimize. Since every version of each declarative configuration is in version control, we have a complete history of every deployment. And since these files are all declarative, it's really easy to just revert back to a previous state. So the operations team just needs to feed in one of the previous configurations to the platform, and it'll revert itself back. Back across Acme, in the mortgages team, Emily's API has just been deployed. Compared to before, this has been a much less frustrating experience for her. Now she's not being slowed down by tooling or process. In fact, it's helping her to go faster and to spend more time doing the things that she loves, which is the actual coding and problem solving, not the constant refactoring and delays. The end experience for consumers is so much better as well. Simply building APIs is not enough for them to be consumable and reused. They need to be consistently discoverable, secured, documented, and reliable. And through APIOps, we're ensuring all of this for every single service. This means that Acme's portal is now a thing of beauty. It's a catalogue of products where each product is a well-designed API. And it doesn't take Acme long to deliver new ones so that they can constantly capitalize on market opportunities. All of this means that Acme can now operate. Oh, great. My PowerPoint has died, but we'll keep going. In summary, all of this means that Acme can now operate with speed and with quality throughout their API lifecycle. They're not having to make these trade-offs between delivery speed and delivery quality anymore. And with APIOps, everybody, every organization can achieve the same level of automation and the same benefits in their API lifecycle. This isn't just for Acme. So every single one of you is able to get going with APIOps today. Before we close off, I would love to see the poll results, if we can have a look at those. Perfect. Thank you for publishing. Oh, this is a very interesting split. So I've been asking this question actually at a few events that I've been doing over the last few months on APIOps. And this matches exactly the results that I've always seen, which is that 75 to 80% of people are having to make this trade-off and are having to either sacrifice quality or to sacrifice speed. And 20 to 25% of people, only 20 to 25% of people are able to achieve both. But we want to help you to get towards that state where you're achieving both. And APIOps is a really great way to do that. So thank you very much, everybody. Enjoy the rest of Destination Scale.